Hello, today I'm going to give you an overview on utilizing a local large language model for retrieval-augmented generation, or a local LLM RAG. I'm Charles William Marshall, and those are how you can contact me. In retirement, I've been gathering PDFs for the local history around Mason County. And the question is, once you gather a bunch of them, how do you find something in them? I've heard about artificial intelligence, and many people worrying about it. I believe it's a centuries-long progression and not something to fear. Okay, you should know that I was, and by training, an engineer, and I believe an engineer's job is to think of ways to get out of work. So I think AI has always been used as anything. I think AI is and always has been using a machine to do something that previously only humans could do. And so examples are calculating. First, it used to be you had to do it in your head. Then they came up with slide rules. Then they came up with mechanical calculators, and then electronic calculators, and then computers. Another example of mental AI is originally in the Middle Ages, a craftsman figured out what parts he needed and did it all in his head and created it straight from raw wood or raw materials. But then he got apprentices and people helped him in his shop, and he came up with lists, or lists were generated so that if you wanted to build a chair, you went to the list that told you what all went in a chair. And then you got computer-aided generated lists where people just went to a printer and it printed out, and here's the things you need to build the chair. Large language models work by pre-training them with a large amount of unlabeled and self-supervised data as text and string-like things. That sounds complicated, but it does that by looking for patterns in the data and the ways that it produces generalized and adaptive input. This is much like when you send somebody to school, they read a lot of books. Well, computers can't read, so how do they do it? It looks to find patterns, and they store them as parameters. And we're not going to get into how they find the patterns. I'm just going to talk about concepts. But for example, the large language model GPT-3 was trained with 45 terabytes. That's that many pages of text, and identified that many parameters. And if you want to read more about any of this stuff, each of these underlined that you can get in the accomplished PDF is a link to web articles or videos that tell you in more detail. My goal here is not to tell you how to do it, but just to give you an overview and maybe some places. So the raw data is fed into a transformer. The transformer identifies the patterns in the data, and training a large language model is when data is fed through the transformer. It stores the patterns that it identifies as parameters, and during the training, the model learns to predict the next word in each sentence as it's being fed data. So you feed it a sentence and it reads the first word, and based on that it tries to guess the next one. And then it looks at what the actual next word is and decides whether its prediction is working or whether it needs to change something. And it's just an iteration process. So it breaks the text into tokens and embeds each with a vector. The data where the vector's parameter values control the token's vector. Now that sounds complicated, and when you're dealing with that many parameters that it's really dealing with, it is. But let's look at a simple example. Let's assume that we're trying to build vectors on a man, a German Shepherd, and a Border Collie, and we decide the two parameters we're going to work on are the weight and the height to build our vector. Well, this man at least, weighs 220 pounds and is 76 inches tall. The German Shepherds 80 pounds and is 30 inches tall, and the Border Collie is 40 pounds and 22 inches tall. If we try to plot that, we get a plot that looks like this, where we start at 0. The horizontal axis we get heavier, and as we go up the vertical axis we get taller. And so if you drew those 3 points, that's where they would be. And when we talk about a vector, we talk about how, the line that would go from 0 to each of the 3 points. I just said that when it reads, it tries to decide whether its word is close to the word that was actually in the text it was reading. And it has to find the distance. And the way it finds the distance is just simple math. We know how, on a 2-dimensional grid, to determine how far it is from the Border Collie to the German Shepherd, and we can decide that that distance is less than this distance when we're trying to evaluate how close they are to each other. Now, I'll grant you, when you put 3 dimensions on, some of the people in the class can visualize it in their mind. And when you get to about the 5th or 6th dimension, which is you can't do physically, but you can do mathematically, it gets really hard to do mentally. But the computer can do it, and that's how the basic concept of how it's doing it. Okay, so the large language model uses not 2, but n parameters. The n for GPT-1 is that number, 117 million. We see that the parameters in GPT-3 went up to 175 billion. In GPT-4, and I'm not even going to say that number, but it's a lot. The newer models tend to be larger. It tends to be, and the way that people have tried to get a smarter machine was to work on more parameters. This takes a big hardware and resources with a lot of energy to run. All right, so the weakness of any large language model is that you train it once. The training to build the model must stop before you can use it. So if you're putting in, for example, world history, and you build until January the 1st, 2025, you can't ask it about what happened on the day that Mr. Trump was inaugurated, because it was never taught about when Trump was inaugurated. The model has no way of knowing anything that happened after the training stops. It can't be exposed to all the information in the world. And even after it reads that many pages, there's still pages it hasn't read, and they may be the pages you're interested in. One way to augment an LLM is with Retrieval-Augmented Generation. It's abbreviated RAG, and we're just going to say RAG from now on. You build the knowledge set on a topic that specifically interests you. In my case, it's going to be the PDFs of local history. Adding this knowledge to your model creates a purpose-built solution for your use case. I think of it like a large language model. If you were talking about a sportsman, a large language model's concept is, I don't know what sports you're going to play, so I'm going to teach you how to play all sports. With RAG, you say, I want you to be a really good horseshoe thrower, so I'm not going to worry about how to do lacrosse or anything. I'm just going to give you all the nuances and all the experience about how to do horseshoes. In my case, I'm going to train my model, my RAG part, I'm going to train on local history. You can continue to add knowledge as it becomes available. So if I want to add something to my local history, somebody says, well, that's interesting, have you seen this book? And I get a PDF of it. I can just add it to my RAG. All right, so training on large language models require immense investments. And companies such as OpenAI plan their investment, and they pay for it by charging access to their sophisticated models. The ones that they let you use for free are, quite frankly, much like when they used to give away cigarettes at the opening of college. The theory is if they could get you hooked, then you'd pay for the rest of them. If you use a large language model that's online, you forfeit control of any information in the query you send to the online LLM. Today I'm going to describe one specific open source alternative, and I put all these on my laptop. So the large language model we're going to use is Ollama. It is an open source piece of software I think it's built on Ollama, which is a database that was created by Facebook and the Facebook company, but Ollama is open source. We're going to prepare the PDFs with a software called Marker, and we'll talk more about that, but it's also open source. And in each case, the PDF has got a link. If you click on or open the PDF and click on the link, it'll take you to pages that will tell you exactly how to install all this stuff. The user prep interface supporting RAG is OpenWebUI. In each case, the underline indicates, like I say, how to install it. There are more than one. This is not the way, this is a way. So I'm not telling you that this is the only way. I'm telling you this is a way that I found that worked on my Mac. The local large language model needs a beefy computer. Okay, I purchase Mac laptops like some of my friends purchase expensive fishing boats. The hardware that on the computer that I'm using is an Apple M4 Mac. It's got 12 performance CPUs and 4 efficiencies. It's got 40 GPUs. It's got 64 gigabytes of memory and 4 terabytes of solid state. So it's not the beefiest machine out there, but it's got a lot of horsepower for a laptop. I did not use Docker. I usually like Docker, but I did not use Docker because Docker currently can't access Mac's GPUs. And GPUs are graphical processing units. Originally, the thing that was most intensive was doing the math to figure out how to display graphics on computers. Over time, people have found out that they can use the GPUs for all sorts of math projects, and Ollama knows how to get to those GPUs. Docker doesn't. So if you put Ollama or any of these other software in a Docker dock or a virtual machine, you can't get to any of the max GPUs that you paid all the money for. So while I like putting things in Docker to have it isolated from everything else, I did not. This stuff is installed natively on my Mac. Okay, so once you've installed Ollama by following the links in that link that I had back there, you can type Ollama help and it will give you a list of all the commands. If you list the models on my local machine, these are the models that I have. That was the command Ollama list, and it tells me these are the models I have. Think of maybe them as transformers, and this is the relative size of them. Note that this Llama 3.3 is really good, but it's really pretty big. Okay, many PDFs are scans and are harder for transformers to process because the transformers want to be reading text, and they don't like to have to, they can't, many of them can't do the OCR or optical character recognition to get it from an image that's in a PDF to text. So we use a transformer, we use something to get it ready for that, and Markdown is the software that I found that is the best. It preserves the structure in pure text format that's portable. It enhances semantics. It gives a clean representation. If you've seen some PDFs that came through OCR, all the words are split up. It's really pretty bad. That maintains the content. Your transformer is going to have to do chunking, and because the marker is going to provide it with text, it can do it a lot better. And if you want to learn more about using Markdown, there's the link. After you got the marker software installed, here's how you convert a PDF. If you want to convert a single file, that's your command line. If you want to convert multiple files, like as in a whole directory, this is the command that you use. And again, you can learn more at that site. All right, if you're using OpenWebUI, which I've decided is the best way I found to do it, you start it, as was described back there in the link that I gave you a link to, and you point a browser at localhost :8080, which means that all this is going to be done on your local machine, but you're going to have a web interface. And when you first pull it up, it tells you what its default model is that it's going to use. This is where you're going to ask the question. This is a list of the prior questions or chats that you've had. The model has no information on my specific question. It's just whatever it was when they first trained it. Ask it, tell me about Lucy Bentley. It nicely tells me that it doesn't know anything about Lucy Bentley. I can add knowledge by clicking workspace and then go to knowledge and build knowledge locally. This knowledge was built trying to just do it off straight PDFs, and it basically didn't work. And this is using Markdown. If I wanted to add a new knowledge base, I come over here and click this plus sign. When I click one of the existing model bases, it will list all the different documents it knows about. And I can add more to it by clicking that. Here's where I can add a new RAG model. So we had to build the knowledge that we're going to incorporate into a RAG, and now that we're going to build a RAG, we're going to name it. We're going to pick the base model, and then we're going to come down here and add the knowledge bases that we want to include, and we can play with the prompts and so forth. If I ask my Northern Kentucky database, which is the one that used PDFs about Lucy Bentley, it tells me that it couldn't find anything about her because it couldn't really do a very good job reading the PDFs that were not converted to text. But if I instead ask the database that I built with my knowledge base, it comes back and it tells me what I wanted to know. And it tells me that it got that from the remembrances of Lucy Bentley, so that I don't just have to take its word. I can go look at the original thing and see, yeah, that it's not hallucinating. That's where it got it. I decided to do some testing another way. I found in the Encyclopedia of Northern Kentucky something about Mays Lick. And so I thought, well, I'll see if it can find that text and answer a question. So I asked it, who was an early person to survey around Mays Lick? And it came back and told me this, and it was a whole lot more than I expected. And I really didn't expect to see John May. But it tells me the sources, and when I look at the sources, I found out that the place names did say that John May was one of the original owners. And so it had a basis to answer my question that way. I think that I've got a working system. I don't have a system I'm prepared to share with anybody yet, as far as my goal is to get this to the point where somebody can walk up and ask it a question and it will give them a reliable answer on Washington and Mason County history. But I got to do a lot more testing and refining and testing this different variations. But much like my friends will continue to learn about their fishing boats over the years, I'm going to continue to learn about using a local Ollama large language model with RAG. And I expect I'll continue to learn and continue to enjoy it. You can get a copy of this at CWM class for the current status of the project. And now I'll see if you have any questions.